between fans and no need for additional power for those fans. We do support QoS 8 levels, and we follow the 802.1p standard. And both links, all links can be modeled within Link Planner. In terms of a UI to the radio itself, if you're familiar with our PTP 500 and PTP 600, you'll find the UI very familiar. It's virtually identical with some incremental requirements associated with the license bands themselves. Likewise, within Link Planner, if you're familiar with it, you can plan links and networks that are composed of both licensed and unlicensed in a common planning tool, common planning application. The Link Planner will provide you a bill of material as well as performance expectations that you can use. Give you a close-up of the modem itself. Pretty straightforward, very clean design on the front end. There's no connectors on the back end of the radio itself. Everything that you need is on the front end. On the left-hand side is the IF connector to the ODU, the RF element itself, along with a status LED. You can see the 1+1 connector, RJ45, as well as the 1000 base T connector. If you're going to use fiber, there's a commercial off-the-shelf fiber FPF connector that will slide into that receptacle in your own business. It is a NEG 48 powered unit, although we do have AC power supplies for the unit itself, if that's the approach that you're going to take. And on the far right side, you see the ground plug. It's a very typical deployment, very straightforward, clean design, nothing esoteric or fancy about it. You'll have your antennas, your ODU. The ODU itself can be direct mounted to the antenna, or it can be remote mount, and Motorola does offer complete remote mount kits with all of the bits and bobs that you need to do that in one bag, so very, very simple and straightforward in that regard. And then the compact modem unit would be mounted indoors unless you're mounting it outdoors in a NEMA enclosure or something to that effect. But nothing unique or special about the deployment in that regard. In terms of configurations, we support all of the common configurations, 1+0, 1+1, 2+0. So depending on the level of redundancy that you require, or the level of capacity in the case of 2+0 that you'd like to achieve, we've got a great deal of flexibility there. In the photographs on the bottom left side, you can see the direct mount approach that I referenced earlier. On the right-hand side, you see either a 1+1 or 2+0 configuration, but it would also provide for remote mount deployment as well. 3 basic networking configurations that are supported and outlined in the user guide and network planning guides that we provide. Star topography is fairly straightforward. Ring topology, in which case you'd be using a switch to direct that traffic, and of course the traditional last mile connectivity. All 3 of these basic configurations can be tied together for more complex networks if that's what your network requires or dictates or intends to grow to. We do have networks very similar to what's illustrated here deployed today, using not only PTP 800, but incorporating our license exempt platforms as well. So a great deal of flexibility to meet your network requirements, traffic routing requirements, redundancy requirements, etc. I mentioned adaptive coding and modulation earlier. Adaptive coding and modulation is really something that comes from our heritage in the license exempt space, something that we pioneered in the PTP 400, which has subsequently been retired after many years of good service, and is reflected in the PTP 500 and the PTP 600. We basically perfected adaptive modulation on those platforms, and we've carried over that expertise into the licensed market. First and foremost, it's a hitless and errorless implementation. We will modulate up and down the ladder without losing packets and without dropping the link itself. We will shift modulations very, very quickly, depending on the weather conditions, and as I think we all know, weather can change very, very quickly. I'm based here in Chicago, and I can come in the morning and it's snowing, and I can go home in the evening and it's 70 degrees out. So those atmospheric changes have come in and they roll out, and your network needs to be able to respond to them very, very quickly. You can, as an end user or network operator, define the maximum and minimum modulation modes that you want to support. So for example, if you're in a ring architecture and you want to be able to redirect traffic in a different direction based on the modulation mode and essentially the capacity that that particular link is providing, you can do that. So a great deal of flexibility in how you configure the radio to take advantage of the adaptive modulation and coding. Very easy setup. everywhere from planning the link in Link Planner incorporates adaptive coding and modulation. The configuration of the radio itself incorporates either FCC or Industry Canada, or if there's anybody following the ETSI standards, all three are incorporated into the configuration of the radio itself, so you don't have to worry about license violations, etc. That's incorporated, and it's relatively easy to change those configurations should you need to change the operational characteristics of the radio itself. The best part of adaptive coding and modulations with respect to Motorola is it's included in the base radio itself. There's no extra charge or cost for ACM. At the end of the day, well, why would you consider adaptive coding and modulation? First and foremost, it's higher link availability. Essentially, ACM allows you to increase your fade margin by shifting to lower modulations mode. You don't have to plan for the worst case scenario in order to maintain your link. That'll improve the overall availability of your link during those severe atmospheric conditions. Greater capacity. The radio will operate whenever it can at the highest modulation rate available and really increase the capacity of the link as a whole while maintaining the availability. In terms of enhanced quality of service control, the graceful link degradation and recovery really allows for end-to-end service. If you drop your link, a traditional microwave link, and have to reset, not only does it affect the microwave link itself, but it'll affect downstream network elements like routers and switches as well. So while your link may recover relatively quickly, you got to wait for that recovery to trickle through the network itself for those routers and switches to react to it as well. Whereas if you're maintaining that link from an availability standpoint, you don't have to worry about that trickle-down effect. CapEx and operating savings are also present with the use of ACM, in that you can reduce the antenna size to achieve your range or achieve the capacity of the network link you're looking for itself. That alone can save you on tower mount costs and acquisition cost of the antenna itself. So all in all, 4 fairly significant benefits to adaptive coding and modulation. And again, Motorola includes it as a standard element of the PTP 800. Very flexible network management. If you're not familiar with it, Motorola does have what we refer to as our one-point wireless suite, which is composed of a number of elements. You can use one or more of those elements at your discretion. The wireless manager element not only can provide fault management of the PTP links in your network, but also the PMP network and the mesh network if you're using those elements. If you happen to also incorporate Motorola's WLAN portfolio for indoor Wi-Fi, those same elements can be managed within Wireless Manager itself. You can remotely manage the PTP 800 via a web browser, dialing direct into the radio itself through Internet Explorer, by example, or Firefox. And we also publish via an SNMP V1 and V2 a collection of different MIBs. I've itemized them there, but we can also provide the MIB library is downloadable from Motorola's website if you'd like more details on that itself. I mentioned the tool set earlier. So we obviously have PTP Link Planner, which would allow you to plan not only a link but a network, or work with Streakwave to do that on your behalf based on the offer that Richard put out there on the front end of the presentation, which is fantastic. Once that link is planned, it can be transitioned over to Wireless Manager for management if you're not already using your own tool set to do that. Give you a quick snapshot of Link Planner if you're not familiar with it. Link Planner is a very advanced network planning tool for point-to-point, Motorola's point-to-point links, and it will allow you to plan a single link or a network of multiple links. You can coordinate both licensed and license-exempt links within Link Planner. It allows you to rapidly model different attributes if you choose to change them. You should choose to change them, by example, changing dish size on one end or the other, or both ends. What does that do to your overall performance? If you raise your antenna height, etc., it allows you to inject anticipated interference into the link itself, and it pulls topographic data from Google for display purposes, so you can do a virtual walk of the link itself to see what that path looks like. It'll publish to you with a high degree of confidence your anticipated availability, your anticipated capacity on that link, and all other appropriate attributes to seek license coordination and ultimate I mentioned at the beginning of the presentation we had a kind of a wide portfolio of products now, bridging both license exempt and licensed.